This video is on conservation of charge and charging. In your notes, I believe it is just called charging. So please follow along and take notes during this lecture. The essential question is, how do objects end up with an unbalanced total charge? I would prefer that you use the term total rather than sigma. Sigma is the symbol that we use, but it represents total. Great. So whenever you see the word sigma in your notes, you should change that to total or just know that it is total. This lesson covers 5 different topics of how objects end up with an unbalanced charge. I'm going to focus for this video purely on the first 2, on polarization and friction charging. That's because these 2 concepts work better with what we've previously learned, and friction charging has to do with insulators. So it connects with the lab that you did on static electricity with the tape. And that's going to help you to solidify those concepts before we move into other forms of charging. All right, so we have a new variable, and this variable is called charge. It's noted by the symbol Q, a lowercase q, and the unit is the coulomb, capital C. We need to know that the vast majority of charged particles in the universe are protons and electrons, and really the only ones we actually care about are protons and electrons. If you care about quarks, you'll take a higher level physics class or other science class. So protons and electrons. Protons have a charge of +1 coulomb each, and electrons have a charge of -1 coulomb each. Nice round number. Just remember, protons are positive, electrons are negative. The first concept that we need to understand is conservation of charge. And just like conservation of energy, we know that the total charge in a closed system is conserved, meaning that the total charge is not going to change even if smaller parts are changing. So for example, in the system of the universe, there's constantly charges things are becoming positively charged or negatively charged. But if we think about the universe overall, there are exactly as many protons as there are electrons. And therefore, the net charge of the universe is 0. The universe is neutral overall, even though there will be places within the universe that are positively charged and others that are negatively charged. So when we think about, again, total charge in a smaller system, it's really, we can never really try to think about the universe as our whole system. That's way too big and cumbersome. We want to break it down and think about, like, within this box, what is going on, right? So when we think about the total charge in a smaller system, what we mean is the total charge of all the protons and the total charge of all the electrons. And it becomes a little math problem. Okay, so let's take, for example, this particular material. It has 1, 2, 3, 4 protons. So that is a +4 protons. And it has 3 electrons. 1, 2, 3 electrons. So electrons are negative, so that's a -3 electrons. All right, and I'll just go ahead and use pink here. If I have +4 -3, that's going to come out to +1 as the charge. And as we can see, the sigma q, total charge, is equal to +1 coulomb, which makes it a small positively charged object. So how about this one? In this one, we have 1, 2, 3, 4 protons, right? 4 protons. I'll just write that up above, +4. I don't need to write in the P, but maybe you can. And I see that we have 1, 2, 3, 4 electrons. So -4 electrons, that would make our total charge equal to 4 minus 4 equals 0. So our total charge is equal to 0 coulombs. This is a neutral object. And now we have this one. And remember we do the same thing. We add up all the protons. We still have 1, 2, 3, 4 protons. And now we have 1, 2, 3, 4, 5, 6, 7 electrons. I'm not taking the time to write that in, but it'd be good for you to continue those notes right up there. So 4 minus 7 is equal to -3 coulombs. This object has a larger negative charge. So the purpose that in me showing you this is that you should be able to, given a picture, be able to note what the charge is of that particular object. And that's going to come into play as we start to talk about charging. All right, let's get to something a little more interesting. Let's talk about polarization. So an object with a positive or a negative total charge can push or pull electrons in nearby objects, resulting in a positive half and a negative half. I'd like to bring back up this plastic pipe that I demoed in class with the fur. When I rubbed the fur on the pipe, and I don't know if you even heard that, but I don't know if it picks up on the computer, it gains a negative charge. In class, I put this by a stream of water, and I showed that when it came close to the water was attracted to it, and kind of it like bent toward the plastic pipe. Here's essentially what was happening, a molecular view at that. So what I have is a highly negative plastic pipe, and I have neutral water. When the water is just streaming down, those electrons are hanging out near their protons, right? It is electrically neutral. When I brought the plastic pipe close to the water, then what happened is that those 4 electrons, moved over to the side, and the protons were attracted to all of those negative electrons that were in there. I didn't change so here's that attraction, right? So this got attracted to the plastic pipe. I didn't change the actual charge of the water, but I changed the internal, like the polarization. I created a pole where one side was positive and one side was negative. This polarized neutral object will be attracted to the charged object near it, since one charged half is closer and pulls stronger than the other. Here's a little visual of what's going on. So I have this balloon, which has gathered electrons from rubbing against the shirt. When I bring it close to the wall, notice that it polarizes the wall by moving those electrons out of the way. I didn't gain any electrons over here. The wall didn't lose any electrons. I just pushed them out of the way, and now that balloon is going to stick to the wall because those protons are attracted to the electrons in the balloon. And these electrons are repelled by the electrons in the balloon. So I created a positive end of the wall and a negative end. But overall, the wall is still neutral. I still have the same number of protons and electrons. So that was similar to what was happening in the water when I did that demo in class. So now I want to talk about how an object actually gains a charge, becomes positive or negative. So an object and system usually starts out with a balanced number of electrons and protons, neutral. The objects and open systems can become charged when electrons move in and out of an object and their total charge changes. And the key thing here is electrons move. Electrons move. Protons don't move. If protons are moving, we're talking about the atomic bomb, right? That means that we're changing atoms themselves. So we're not talking about protons moving. We're only talking about electrons either moving in or coming out of an object or a system. Okay, so friction charging is when we rub two different insulators together, and it will transfer electrons from one to the other. So this is going to take a little bit of drawing on your part. You might need to pause the video for this. I want you to start by drawing two objects that are both neutral. So we're going to take, let's pretend like this one, or yeah, this one is um, this one is the green one there, and this one is the orange one there. And the key thing that I want you to put in there in your drawings, 10 protons, so 10 plus signs and 10 minus signs on there. I don't really care where you are placing those minus signs as long as they're kind of close to those pluses. And do the same thing on the other object. Since we have 10 positive and 10 negative in each object, they are both neutral to start. Our total charge is 0. All right. Now, when I rub the fur on the electron, so when I rub the fur on the plastic pipe, then the fur it gives away some of those electrons, and so the plastic pipe gains those extra electrons. So I want you in this one to draw those 10 protons. Those protons didn't move, remember? And draw only 5 electrons. And in this one, draw 10 protons and 15 electrons. Now, go ahead and add up those charges and identify what the charge is on this green one and what the charge is on the orange one. And I'm about to show the answer, so pause the video before you see that. Okay, so the charge of it says yellow, but this would be green. The green one is positive 5 coulombs because we have 5 more protons than we do electrons. And the charge of the orange one is negative 5 coulombs because we have 5 more electrons than we do protons. If we add these together, we see that positive 5 minus 5 equals 0. So we still obeyed the law of conservation of charge, and the objects are, the whole system is still electrically neutral. So how do we know whether an object is going to give or receive electrons? Well, it's because scientists have figured it out, and they've written out this electrostatic series for us. So this tells us which objects are more likely to take electrons and which objects are more likely to give away electrons. And I knew that the electrons went into the plastic pipe because it's plastic, and it's higher up on that scale than the fur. So I knew that the fur is going to give away those electrons to the plastic. Quick thing to note here, all of these are insulators. So we're talking about insulators here. So that's the main thing that you need to know from this part of the lecture. What I'd like for you to do is to go to your review of the essential question and jot down a sentence or two for polarization and for charging by friction to help you to solidify these concepts and figure out what you're still feeling a little bit muddy about.